19. So the question is like this: OABC is a square, so four sides are equal, and then let OK be the coordinate of C. So that means the length of OC is K, and we know the another remaining three sides are also K. So prove that two diagonals OB and AC are equal in length. So that means you need to find the length. Okay, the distance formula of OB is equal to OC, right? So we can know the value, the coordinate of A, it should be K0, and B should be KK, right? So for that means we can write down as for 0 is, so O is 0, 0, A is K0, and the coordinate of B is KK, and the coordinate of C is 0K. So therefore we need to show the distance of OB, which should be distance point formula is square root of OB should be K minus 0 square plus K minus 0 square, and that was 2K squares, and then take a square root, and then the distance of AC, it should be equal to square root, so K minus 0 square, and then plus 0 minus K square, which is also equal to 2K square, and then take a square root, so which is equal to distance of OB. Okay, so we finished the first one. And then for instance rule 20, to prove that two diagonals of the rectangle bisect each other. Okay, diagonals, that means OB, it's better for you to draw in the figures. Okay, and then write down a sentence like this: is let the vertex of rectangle be OABC. So what we need to prove is OB bisect AC. Okay, so what does it mean? It should be, how can I prove is OB is bisect AC? It should be their midpoint are the same. Okay, so first of all, I will let the coordinate of the length and the width of rectangle be A and B. So that means the length should be A and the width should be B. So we will get the coordinate of these four vertices should be O is 0, 0, and A you will get A0, right? And then C you will get is 0B, and for B it should be AB. Once you get these four coordinates, you can find the midpoint of OB should be A plus 0 over 2, and then B plus 0 over 2, and you'll get A over 2 and B over 2. And then you can find the midpoint of AC, which should be also A plus 0 over 2 and B plus 0 over 2 again, and also equal to B over 2 and A over 2. So because the midpoint, okay, so the midpoint of OB and AC are the same. Therefore, OB and AC bisect each other. Okay, so the key point of instance drill 20 is, remember, is the midpoint. The midpoint of these two lines are the same. Okay, so then and then for instance drill 21, so OABC is a square again, so these four sides are equal, and PQRS are the midpoint of the four sides of square. So prove that PQ and SR are parallel. So we need to, that means that we need to find the slope of PQ. Is this whether equal to the slope of SR, right? So we can let A be the length up square. So therefore, the coordinate of O is 0, 0, and A should be A0. And then C should be 0A, and the coordinate of B should be AA, right? So I'm writing down like this. And once you finish OABC, the coordinate of OABC, you can find the coordinate of PQRS, right? Because they are midpoint. So P will become A/2, 0. And then Q, which should be the x coordinate is A, and then the y coordinate should be A/2. And then R, the x coordinate will be A/2, and the y coordinate is A. And the last one is S, the x coordinate is 0, and the y coordinate should be A/2. So we can get these 4 coordinates. We can show the slope of PQ first. So slope of PQ, which should be A/2 minus 0, and then A minus A/2. And you will get is A/2 over A/2, which is equal to 1. And slope of B, and other slope is the slope of SR should be A minus A/2, and then A/2 minus 0, and you also get A/2 over A/2 again, which is equal to 1. So you can write down, because slope of PQ, which is equal to slope of SR, equal to 1. So PQ is parallel to SR. So we finish instance 21.